Hi, so carrying on, Mr. Aston's gate post is 30 centimeters wide, while the sign he is considering fit his gate post. So in the previous question, we deduced that, or the previous part to this question, we deduced that the scale factor between the two was 5/6, so like so times by 5/6, and this was 42, and we want to know if this is bigger than 30. So imagine it like this: the gate post, so the gate is 30 centimeters wide, and we need to know if the sign will fit here effectively. So what we need is for the sign to be less, this width here, this one here, to be less than 30. So we do the same. The scale factor is timesing by 5/6, so 5/6 of 42, so that is 42 divided by 6, which is 7, and then 7 times by 5, which is 35 centimeters. So no, it does not. This being 35 centimeters, the sign is too big for the gateway, so no. Okay, so moving on. Question 8. A boat company runs trips from Tenby to Caldy Island. They want to provide services suited to its passengers. On one day, the company records the ages of the passengers, and the table below shows the frequency densities of different age groups. So frequency density effectively is how distributed the density is throughout the interval. So density assumes it's evenly distributed. So essentially what this is for every 1 unit of this interval, there are 1.8 people. So there are 20 units on this interval, and then each of them gives you 1.8 people. So this one here, for example, would be 36, but let's do this formally. So this one here is an interval of 20, and every one gives you 1.8 people. So 1.8 frequency effectively. So this first bit is going to be 20 times 1.8, which is 36. Let's do the next one. So this is 15 times by 2.4, which is also 36. And then this one here is 15 as well, and that's going to be times by 2, which is 30. And then this is 50 to 70, so that's 20, and that's times by 1.5, so that is 35. And then this one here is 30, and it's times by 0.6, so 60% of 30, so 3 times 6 being 18. So then we add these up, and this would be the total frequencies. So from this, we found all the frequencies, and we just add them up. So I get this to be 66. Sorry, this should be 30, my bad. So I don't know why I've written 35 here, that should be 30. So 6, 6, 2, 5, 1. So 150 people total. So the reason we're finding the amount of people is because we're asked to estimate the percentage of passengers who are age 60 or more. And we haven't got to the estimating part yet. The estimating part is going to come from this 60. So notice the 60 is in the middle of this interval. This is where the estimation is going to come in. So to find the percentage of the passengers, we need the total, and we need the amount of passengers to meet the condition we're looking for. So the condition we're looking for is over 60. So the people that are over 60 are going to be everyone in this interval by definition, because they're all above 70. And this one here, we assume that it's halfway through the interval. So we assume that the frequency is equally distributed throughout this interval, and we essentially have to cut this interval in half. So from 60 to 70 would be an interval of 10 times 1.5, which would be 15 people between 60 and 70, and then we add the 18 people from here. So adding the 18 people on, so 15 plus 18, we get 33 people above 60. So now it's 33 people out of a total 150, and we need to write this as a percentage. So the trick here is we're going to want to get this out of 100. So I'm going to just do some trickery here. I'm going to write this out of 50 first of all, because it doesn't directly go to 100. It can be done, but it's not very useful education-wise. So dividing by 3 gets me to 50, so this is going to be 11 out of 50, and then I double it to make it out of 100, so it's 22 out of 100. So we are looking at 22% approximately. So on the graph paper opposite, draw a histogram to show the distribution of ages of the passengers. So allow me to split this up. Let me just check my camera. Okay, great. So on this graph paper, we're going to draw the histogram to show the distribution of ages of the passengers. So first thing to do here is note that I'm not given this y-axis, but histograms are always a case of the data goes along the x-axis, and on the y-axis it will always be frequency density. So let's add frequency density here. Right, so the next thing now is to pick an appropriate scale, an appropriate end and start to our scale. So I think 0 is going to be sensible here, given that a histogram generally should start at 0 because its volume, its area should cover the frequency effectively. So I've got values that are all more or less 0.1s, and the maximum being 2.4. So I've got 1, 2, 3, 4, 5 notches to use. So I think going up in 0.5s and ending at 2.5s is reasonable. 0.5, 1, 1.5, 2, 2.5. So with 10 boxes between 0 and 0.5, that means that every small box is 0.05 and every 2 boxes is 0.1. So let's use this to plot this then. So 1.8 first of all then, so 0 to 20, and a height of 1.8, so that's going to be 6 boxes above 1.5, and we go to 20. So histogram, notoriously, the bars do not have to be the same width. Some can be slightly wider or smaller than others. The next one is to 35, so to here. And it has a height of 2.4, so that's going to be 2 below 2.5, so that's going to be there. Let's draw our line up to where we're going to be, so it's going to be 2 off 2.5, so there, yeah, good. And then let's bring this up here to match it, like so. The next one then is 35 to 50, so this here. And it has a height of 2, so this is a nice straightforward one. So 2, and we're going across to 50, so there. The next one is to 70, so we're going to here, and it has a height of 1.5, and again, that's another quite nice one. So we're going across to 70, so there. And then the last one's all the way to the end, and it has a height of 0.6, and 0.6 is 2 above 0.5. So we're going to go there, like so, to 100. And then I'll add this last line down here. So that's my histogram. So part C, and I may end it here given the length of this video. So yeah, I'll end this here and we'll go ahead in the next one.